Welcome to the HPC Best Practices webinar series. The series is brought to you by the IDEAS Productivity Project, which is part of the exascale computing project of the United States Department of Energy. I'm Osni Marquez. I'll start the host, the webinars as a host here, waiting for Eric Palmer. We are from LBL. So the webinar is Secure Software Programming, Practice and Development. And the webinar will be presented by Nitin Sukhijan. Nitin is an associate professor in the Department of Computer Science and director of the Center for Cybersecurity and Advanced Computing at Slippery Rock University of Pennsylvania. He has been involved in research and management of various projects related to the security and software challenges in industry and academia. His research addresses the threats to the confidentiality, integrity, and availability in HPC environments, and he uses HPC capabilities to study and understand the multifaceted complexities of anomalous behaviors, also to model and simulate complex technical, organizational, and human systems instrumental in providing security and trust. We have issued more than 140 tickets for today's webinar, and all attendees have been muted upon entry. We'll receive questions through the Zoom chat and also Google Doc. I'll paste that address in the chat momentarily. We have asked Nitin to add breaks during his presentation so he can respond to the questions that come in. One note here is that I'd like to thank everybody who joined the webinar series, the HPC-BP series, webinar series. This is the last webinar in the series under with funding from the DOE Exascale Computing Project, but we have plans to continue the series, so stay tuned. With that, I will stop my sharing here, and then you'll take over.
Hello, everyone. Can you hear me?
Yes.
Thank you, Osni. Thanks, Osni, for the introduction, and thank you all for joining our seminar series. I am Nitin Sukhijan. I will be your host for next 1 hour, and I'm going to discuss a topic on software programming practices and development. Again, that's the key right here. I added a patch, which normally we add to our systems. We are not worried about security. We are trying to patch security once we develop the software. So a little about me, which I was going to mention. I'm associate professor and director of the Center for Cybersecurity and Advanced Computing at Slippery Rock University of Pennsylvania. I'm also a Law Inspection National Lab affiliate and Campus Champion Leadership Team member. I'm also part of the ACM security education chapter. My main area of focuses are high-performance data analytics with main focus on cyber resilience. If you are interested in the talk or trying to, work or collaborate further, please email me at nitin.sukhijan@si.edu. If you want to see my work, please Google. It's all there. With that, I'm gonna start with a brief outline. I have exactly 50 minutes, and then I'll try to stop and also have 10 minutes for Q&A at the end of the session. So I'm gonna talk briefly about why are we discussing about the area? Why is this important? Why security is important? We all are aware of software development life cycles, but what challenges are leading to security in the software development life cycle? So we'll discuss about what SDLC means, how do you embed security, what secure software development life cycle means in today's world, then followed by how do we design for security, that's threat modeling techniques, and then we discuss about our static analysis and analysis tools, which we are using for testing softwares. And then lastly, we're gonna discuss, we're gonna have Q&A. So the first thing with our agenda is why are we talking about secure software development? Because what's the need? Why are we discussing how is this so important now? So let's discuss some cases which happened, in previous 3 years, which basically are not one of the cases. There's so many cases happening every day now, but they're major cases. So one of the most sophisticated cyber attack which happened in software lifecycle was a SolarWinds attack in 2020. It was supply chain attack leading to data breaches globally. Here, the threat actors, basically, they tried to turn the Orient software into a weapon, where they tried to gain access to all the major government systems and then thousands of private systems around the world. So they actually infected more than 18,000 customers globally, including all the major US government departments, which is DOE, DOD, and Homeland Security, and all of this we can think of. So we learned this lesson that not enough is there to build a firewall, and we are hoping that's going to protect us. No, it's not going to happen. We also need to actively seek out the vulnerabilities in the system. What are the weaknesses, which we do not do? Second case we're going to discuss is the dependency confusion attack, which basically is an attack from 2021 and was unveiled by a security researcher, Alex Brzan, who basically talked about the third-party dependency. The target is we all are using so many software, we're trying to use third-party dependencies for the softwares. However, if you look at the diagram on the right side, if I'm using a private package, which is QWeb, and if I do not know where the dependency lie, right? It might be some container. However, if somebody is trying to, host a different container, which has a malicious, the same dependency name, then your software will basically depend on the malicious dependency. So what they did was they tried to inject malicious code into dependencies, which the application uses, and which allowed them to access the application's data. And they tried to, with this, they were able to break the system belonging to Microsoft, Apple, Uber, and Tesla. So what we learned is that developers must know about the risk of dependencies confusion and important secure package management, because we are patching it up, but we're trying to see how the patch and package comes into picture as a whole. Next case I'm going to discuss is the network data breach, which happened in 2022. I think I'm going to move the screen if nobody is visible. Which basically targeted the communities of interest cooperation portal. Now, we all are scientists. Some of us are scientists, some of us are not in academia, BV industry. We all are try to use some kind of collab tools to work with each other. This was the breach which actually tried to, target the communities of interest portal, and the cybercrime group, which was SeedSec, which is the political motivated groups. They tried to attack it. They said that this was a response to NATO's human rights violation, and because it was fun to leak documents, where they leaked 3,000 stolen documents with almost 9 gigabytes of sensitive data, which was only intended for NATO countries and partners. Then we learned that, well, we need to promote secure practices. We need to basically tell them what are the vulnerabilities, how to minimize the vulnerabilities, how can we tell people like what vulnerabilities can be exploited and used to inject malware in their codes. We also need to conduct security reviews regularly and also use automated tools to basically securely identify the potential weaknesses in our software. Last case we're going to discuss today is going to be the most recent case and the biggest data theft of 2023, which is a MoveIt data breach attack, which happened in this year and was basically done by a ransomware gang called Clop. It's a zero-day exploit of progressive software MoveIt, transfer enterprise file transfer protocol. So we all use FTPs, right? All the transfer protocol to exchange our file. This data theft basically used by hacker allowed them to inject SQL command and access the databases of MoveIt customers. And more than 2,500 organizations were basically attacked, and 62 million people as of 2023 October were affected by this breach. So we learned that we need to actually figure out what are our indicators of compromise, which can be exploited and attacked and used by the malicious actors. So I'm not trying to scare anybody off. We're just trying to give a brief outline what is really going on here. So the question is, what exactly is happening? There are breaches, yes. We are patching, yes. But what exactly is going on here is the cost is increasing in billions now of these cyber attack, right? Now I'm going to discuss the challenges. So we talked about increasing complexity in threat vectors, because the challenge is that we have a number of unpredictable and highly dynamic factors. The first being the heterogeneity of internet networks, applications, server, and virtualized infrastructure. So if you look at your own system, your clusters, your own infrastructure, it's increasing exponentially, and you do not even know. It's really difficult to keep control of the application, because you might have multiple network engineers, reliability engineers, but they are working on different open source networks or applications which are trying to gel together to form like this one huge infrastructure. But we do not know how these things interact with respect to security. There is a proliferation in the hybrid system models and orchestration of many complex software devices. We're trying to orchestrate all these complex services and containers, try to have everything virtualized, posted on cloud. But again, who is managing the security? Are we looking into the patches? Are we trying to install every single soft service? When we try to converge this big data HPC cloud services, that's again a challenge itself from the development point of view. Security at last is not even considered. Then our reliance more and more of applications are basically relying on open source packages. The goal is to have less cost, right? Third-party dependency. We have multiple of these. Right now, we think it's coming from a mirror file, but again, mirror can be a, like I said, there will be a duplicate, which will be a malicious file. And then we all are dependent on digital data transfer. Like we all are, any business you do, data is important, any sizes, they are transmitting data on different protocols. Now, risks continue to increase, right? However, the vendors are highly unlikely to know that the software, the apps, or the updates they basically are selling or updating or installing are infected by malicious code when released to public. So that's the biggest challenge we have. Now, why are we having this channel? Because the reason is the security is never a priority. When we develop a software, right? When you design a software, often, the design priority is, trump security. We are looking into cost. We're looking into, okay, we want to be cost effective, right? And security always comes with additional cost. You need to hire somebody to do that. It also, we need convenience in software development. Again, security comes with inconvenience. It basically means that, if we, every time I add extra step level of security, that's inconvenience to a person, right? That's basically, we're looking into, for example, if I add a different policy for password and say, oh, well, it's a different policy. You're making us change password every 3 months. That's, again, it's inconvenience, but it's required. We talk about faster builds. We need to have more and more versions of software build, different iterations. And then as iteration of build, we try to lose the security there. Open architecture, we're trying to build open source architecture. Now, again, open sources are good, cost effective, but again, open sources, you are supposed to also contribute to them. And if you can't just keep taking it, you need to make sure it's open architecture with all the security inbuilt from your aspect. Then backwards compatibility, right? We are looking into version 8, 9, 10, 11. But if there were patches in version 8 and you want version 9 to be compatible with version 8, that means you are inheriting all the patches from version 8 into version 9. So that's also an issue in development of the security in software. Now we can discuss about what software development lifecycle is basically, which we all are aware, and then followed by the security development in the lifecycle of software. So software development lifecycle is basically, it's an easy term, right? We all are aware of, we have been developing softwares, if you are in the area of, in computing, computing, we are developing software from and we have been taught this traditional software development lifecycle methodology. That means that we need to gather requirements, right? The first step is, let's gather requirements, that mean the user stories, what the user needs, stakeholders needs, and then let's design the software. Once we design, we develop the software, we code it, and then we test it and say, okay, here you go, we deploy it, and then we maintain it as per need by required, or this software become dead after some time. So it's a generic methodology used by most software developers, which helps us to basically lead to beneficial results. However, if you look at this whole picture, security is nowhere there, right? We have forgotten, right? We never discuss security. So if you try to talk about secure scientific development lifecycle, we're trying to mitigate the risk of software vulnerabilities with best practices and tools for securing our scientific software development. So if you look at the requirements analysis phase, we have to add risk assessment to that phase. That means we need to analyze all the risk, what can go wrong, in the first phase. Designing, we need to add threat modeling in the designing and development phase. Then we try to add static and dynamic analysis and testing, and secure testing and assessment, and operation assurance in the maintenance and testing phases. So you need to add extra steps to actually add security to the design of your software. So we are not basically designing software in traditional sense. We're trying to add security by design initially when you start actually trying to talk about software. This is one of the more recent or commonly used or most commonly used lifecycle. It's called DevOps lifecycle, right? Which most of us are aware of. Here, the developer teams and IT operations team work together. That's what's called DevOps. The collaboration is very, very nice. It leads to superior quality throughout the system. There is a continuous deployment and integration of the software. There's monitoring, feedback between operation and developers. And then we can talk about security in different phases if you're allowed. Testing oversees the manufacturer code against problems that arise after compilation. So we're basically looking into after we compile the code. We can utilize automated tools also after the developers check. There's a development which is continuous, and there's risk assessment where developers can take advantage of running the application. However, the problem here is that security issues are only detected until software has passed all the tests through the security team. So we're not talking about security from the design phase or from the beginning of the lifecycle. We're only doing after the fact that has been gone to all the testing teams. So what we do is we try to look into how security can be inbuilt in the same cycle DevOps. It's called DevSecOps, right? Security in DevOps lifecycle. So what we do in planning phase, right? We try to address technical security. We can investigate firewalls, antivirus solutions, password management techniques, backups, choosing or different security policies for production, training staff on different tools which are there, which they can use to develop, during the lifecycle. When you do the coding step, you're trying to basically allow the training or the trained staff will use different IDs, which comes in inbuilt security plugins. So you can actually look into vulnerabilities, right? You can install different plugins to investigate hidden weaknesses. You can use Open Web Application Security Project, OWASP, or you can use Payment Industry Data Center, PCI, DSS, or you can use CVE or Common Vulnerability and Exposure Database to look into different vulnerabilities which can be exposed in your code, and try to basically make sure before you encode, you're aware of the vulnerabilities and you do not have any kind of vulnerabilities in your code. Then you build your code and then use static analysis tools, which basically will help you to scan your source code, binary code, for some kind of underlying security flaws. Then you can use dynamic code to, when you run your application, to basically analyze the front-end vulnerabilities. During testing phase, you can look into chaos testing, which will help you to perform health checks. You can also look into the first testing, which will help you to basically test your application on various invalid or random inputs to your system. In release phase, you can look into continuous code signing, which makes sure that you are implementing corporate security policies as relates to software development. Then deployment phase, you want to make sure that there is signature verification, so we can actually verify the integrity of the application signature to ensure the application is coming from a valid resource. Then on operation, you can use RAS, which is the security technology that uses runtime instrumentation to detect and block computer attacks, utilizing the information from inside the running the software. Then lastly, monitoring phase, which is very important, is you can use the entity and behavior analytics, like OBEA, is a type of security solution that discovers threats by identifying activity that differs from the baseline behavior. So in this way, you can add security in each and every step of your life cycle, not just at the end when everything is done. Before I move on, I'll take some questions if anybody have any questions at this stage before I move on to the threat modeling. That's the, you see the text.
Nitin, I'm not seeing any questions at this point.
Okay, that's good. Okay, I'll move on then. Thanks, Eric. So now we're going to talk about how do we design security in our software development lifecycle, right? So designing, that's the threat modeling, a very important phase and often overlooked. So designing for security, which is now everybody's crying for, because you are done basically patching up the software, after the fact you get hacked, right? So the goal of threat modeling is the following. It enables organizations to anticipate threats rather than reacting. So you're looking to proactive approach. It will also help you to prioritize resources, allowing the organization to look for what are the most important vulnerabilities you need to tackle first. It also helps you to promote the development of secure software and also to try to reduce the risk and, of course, the cost of cybersecurity incident, because we all think we are secure because we have outsourced our cybersecurity to XYZ third-party vendor. But you have to also acknowledge the fact that the third-party vendor gets hacked, you are also getting hacked along with the third party, and you do not know anything about how third party is interacting with your security. So what is threat modeling? Threat modeling is basically assessing risk, a security risk of a software from adversary's point of view. So we are looking from your software, not from a developer point of view. You have to get the mentality out, because from your point of view, everything will look nice. You have fulfilled the requirements of the client. You have doing the perfect work. It's working as it is. But now you have to look from a malicious point of view. See, what can you attack? What can go wrong? What can you use? What are the backdoors which I can use to basically destroy your software? The risk here is defined as the potential for loss, damage, or destruction of an asset as a result of a threat exploiting a vulnerability. So what exactly we do in threat modeling? It's a proactive approach for identifying, managing, and mitigating potential threats. So we're trying to identify, manage, and trying to mitigate. So we do the three-step approach we're trying to define all the system components, right? What are the different assets of your software? What are the entry points? How the data will flow, go in, how data will come out. You recognize potential threats to the data entry points. Then you to categorize the threats into different categories and implement the countermeasure. How do you counteract with those particular threats? The goal here is to improve system security and minimize the security risk. The components of a threat model will be the 6 components are: first, system overview, which means that you need to understand how the system and software function. So you need to elaborate on the interaction of your software. Who are the use case actors? Who are interacting with your software? Is it just an admin, a user, a new user, old user? Who can interact, right? Stakeholders, and how can they interact? Then you look into the assets, the information that needs to be protected. For example, what's important for your system? Is the data, is what I can steal? I can steal the configuration, I can steal intellectual property. What can I steal if I'm a malicious person from your software? Why is it important to me? If it's not, then you're safe. But normally something is there in your system or a software which can be used by the potential hacker to do something malicious. Adversaries, who might be interested? Once you know your assets, okay, suppose my asset is data, right? Or intellectual property. Who can be interested in compromising my system? They can do for fun, like I mentioned. They can also do for political motivation. They can also do because they want to destroy your reputation. Then attack vectors. How many adversaries might attack the system? How can they attack? So you look and list the attack vectors, then look into weakness and vulnerabilities, points where adversaries could exploit. So you look into, for example, right, my garage door there's a hole in the garage door, right? Is a vulnerability, it's a weakness, can be exploited by the malicious people or by rats, right, to come into my house. So you have to, even though it's a small patch, you have to do it. It's still a patch, right? Still somebody can see it's a patch and destroy it. You can't change the garage door, but still you can do something which is more concrete than just putting a duct tape over that, right? Just to give an example. Then mitigation, what measures can we take to lessen the risk of vulnerability? So we do the 6 components of the threat modeling. So how do we process? The steps which we take in threat modeling will be these. So you decompose your system into assets, users, entry points, and data flows. So what are the main assets, main functionality? So overall functions of your system, what all my system does. Then who are the users or the actors of my systems? What are the entry points to my portal or to my software, and how the data flows between these different assets or different functions of my software. Once you know your total system, which is basically in design phase, you will identify threats. You will identify potential threats from all the perspectives, malicious, developer, and then try to analyze the weaknesses that could be exploited by the malicious folks. Then once you know the weaknesses, you try to estimate the impact and likelihood, what can happen, because not every threat will have likelihood of 100%, right, happening. It might be 1%. You need to concentrate on the most important threat, and then try to strategize to look into the countermeasures which you can develop to reduce the risk. Then you document and communicate, you keep recording all the findings, action, and unresolved risk. And as the software develops in different iteration, you keep updating the model as software develops and also as the threat evolves. Because if the version 1 is coming 2023, that might have different threats and as opposed to version which comes 2024. So as threat evolves, your model will also evolve. So now I'm going to discuss one of the most mature threat strategy or methodology is called STRIDE. STRIDE methodology it was developed by Microsoft. It's used to identify and categorize potential threats. Typically, it's used to do the design phase of a system, and it covers mainly the technical aspects, not the physical aspect of the system. So here, STRIDE is an abbreviation for S stands here for spoofing identity, T stands for tampering with data, R stands for repudiation, I stands for information disclosure, D stands for denial of service, and E stands for elevation and privilege. These are the STRIDE categories in which we try to categorize our threats. So the first is spoofing identity, right? Here, what is spoofing? An attacker can impersonate another user. For example, right, if I work for a DOE lab, I can basically impersonate as an admin and try to take over the identity of somebody like my manager, right? Or send a spoof email, right? Like saying, okay, you will believe it's coming from a manager. It's not from a manager, it's from me. So here I'm trying to spoof identity, IP, ARP, DNS, And then damage which can be caused will be unauthorized access. Somebody can steal the data or damage the reputation. For example, it's coming from, I said department head, right, of your department, and he or she does not know, and it comes from them. Everybody clicks on the link, and here you go. It's stolen. The data is stolen, or your passwords are compromised. Mitigation is two-factor authentication, encryption, education. Education is now very important. You need to educate and train. Not just training, like people like, okay, do this cybersecurity training, but you need to actually, do some kind of real life threats. That means that like we do fire drills, you need to have cybersecurity drills also in your organization so people are aware of spams or how do you act with the spams. Tampering with data. So that's T stands for, in Stride. Here, that means unauthorized alteration of data, where we can tamper the data, the code, the configuration. Here, the damage which can be caused is we can, again, do the unauthorized access. Somebody can have false information plugged in, and the lack of data integrity. Here, for example, I open up a database, I change the log files. That's basically tampering, right? That means nobody knows that I entered, or somebody came to your office, or was checked in, or was there. Somebody steals something from your office. Nobody knows, right? Somebody runs a job on your system, and nobody knows there's no log of system. Somebody tampers with your job scheduler. Nobody knows, right? So it's basically tampering with data. So how do you mitigate? Again, checks for data integrity, secure transmission protocol, and restriction aspects. That means that you try to implement different principle of least privilege. That, for example, I have a privilege of an affiliate. I cannot do any work which basically was allowed, right? Even though, I can be allowed to do some of the functions, but no, they will say no. And it takes multiple steps to get this approved, not just one step. Repudiation means that where user denies having performed an action. And I said that I did not, order something on Amazon.com. A transaction can be repudiation, email a contract repudiation. For example, there's a document we send through Google, right? Say, well, I sent a document, I never got it. This can damage the reputation for businesses. This can cause auditing problems. It can also enforce inability for accountability. So what we do is normally we try to have digital signatures, which became more and more common during COVID times. Now we do everything digitally. There are authentication protocols and monitoring. Monitoring is very important, again, because even though you have digital signatures, somebody can still spoof your signatures, right? So make sure it's coming from verified resource. Now, in Stride, D stands for denial of service, where basically you are trying to make a system unavailable to users, which we are well aware of DDoS attacks. Here, a network application system level can be attacked where it becomes unavailable to the alleged users. For example, if I'm trying to log in into a DOE website and it's got, basically there's a denial of service attack on this website, nobody can log into it because right now it's catering to all the bots who are basically trying to occupy all the services from this website. Damage can be financial damage and loss of trust because, for example, Amazon gets denial of service attack. That means if it's down for 1 hour, it loses millions of dollars in 1 hour. Loss of trust, nobody will basically try to log into your website because there's some damages there. So what we try to do is we try to have countermeasure of firewalls, capacity planning, and traffic filtering. Try to filter the traffic. You try to have heartbeat. That means after some time, suppose 3 or 4 attempts, you just lose the connection from the bots, right? And capacity, that means after like 10,000 of requests from XYZ or 2,000, you just cut the connection. Elevation of privilege is the last, which is the E of Stride. Here, a user is trying to gain higher access privilege than intended. So this is very important when it comes to, especially when you have different clearance levels. Which types of the elevation privilege, which can happen is role, access, or privilege escalation. Here, damage can be system manipulation. Somebody can manipulate the system. They can be damage to the system. They can have unauthorized access to sensitive data, which is not required or should not be given. The mitigation will be access controls, patch management, regular auditing, and principal least privilege, which is basically, can be used. We have different models called Bell LaPadula models or Viva model, which can be implemented from scratch when you design the model to have these principles implemented. Then you have limitations, right? Which they are always limitation on everything, right? It's most mature, but again, the limitation of Stride will be no built-in method for risk scoring. You cannot quantify that risk. It's, yes, qualitatively, you can have different categories. It focuses mainly on technical threats, which leaves out physical security threats, which are again important when we talk about cyber physical threats, and relies heavily on the DFD, the data, how data flows through the system. That means that you are looking into some person who actually have really high level expertise of the overall system. That means you want to embed this from the design of the software. Next is RED methodology, again, a reflect model technology methodology, again introduced by Microsoft. It's basically used to evaluate and assess the risk of threats. So here, it's used basically with other methods like Stride. Stride and RED are used together because it aims to prioritize resources that address the most significant threats first. It helps you to give you a scoring system. So again, RED, DREAD stands for damage potential, reproducibility, exploitability, effective users, and discoverability. Again, damage potential means how bad an attack is. That means the potential of damage can be data loss, service interruption, financial damage, and reputation damage. Consequences, again, depend upon severity, right? How bad the attack was. Mitigation, you keep regular backups, incident response planning, disaster recovery planning. Again, if you think that, okay, my services can go down, for example, your monitoring service can go down, how bad it can go. If it goes down for 2 hours, 3 hours, what can I lose, right? Do you have a contingency plan in place? Suppose nobody's in the center and there's only one person operations team is there. Can that one person handle this type of damage? No or yes. Reproducibility, right? How easy is attack is reproduced, right? That means you can exploit scripts, automate the attacks, and manual attacks. High reproducibility results means that you are basically trying to do more frequent damage because you can reproduce the attacks. Now, again, patching the vulnerabilities and implementing IDS systems is very important for tackling these kind of threats. Exploitability is what is needed to launch attacks. So no user interaction to extensive user interaction. So basically, again, it's easier if it is to exploit an attack than higher the risk of its one occurring, right? Because I know if I can exploit this like easily, that means that people can exploit. Once you know that there's a patch or there's a vulnerability in system, it basically is broadcast on the internet, and everybody, all the malicious people can actually exploit the same vulnerability in your system. Mitigation, as soon as there's an attack, you try to educate to the secure programming from the beginning and try to have regular vulnerability scanning of your software. Affected users, right? How many users can be affected? Single user, group of users, all users. So for example, if there's an attack on a big supercomputing facility, who all are attacked, right? Who are affected? The more users affected, the more damage going to occur, because the users might be some users which are basically users who has high clearance level. So what you do is you have to have a principle of least privilege implemented, like different model that even though it's attacked, but nobody can get into the different levels, even though you get access to the network. Segmentation network and different access controls have to be implemented. Discoverability is the last threat, which means how easy the threat is to discover. Threats that are easy to discover to threats that are extremely difficult to discover. Consequences will be the more likely a threat is to be discovered, the more likely it's to be exploited, right? That's pretty common. What we need to know is that we have to test our system continuously with different first testing or regular pen testing and regularly scanning for vulnerabilities. Like as system evolved, you need to have different audits done and also reported, not just for us. Now, how do we take Stride and RED basically, work together?
Can I ask you to pause and
Take
address questions in the Q&A doc? The first question is, can you comment on the impacts to users of Science DMZ? I'm not personally familiar with that, but maybe you are.
Well, the thing is, if I have an example at the end where I have a portal example where basically are doing the collaboration. I will say if you are the impact would be basically tampering the data, right? If you are dealing with Science DMZ, if somebody is trying to use a wrong data which is given by you, their results myself, which were published, or suppose I use a data set from Science DMZ and I publish my results on it. So people keep building on the results. That means that, or we can say, loss of scientific fidelity is one of the most important consequences of attack on Science DMZ.
Thanks, Ed. The next question is, I experienced personal financial damage from someone spoofing an AWS admin, first via email. I failed to inspect the email headers in my panic. Then by my dialing an included spoofed toll-free number, requesting reimbursable funds in the form of gift cards to help trace hypothetical server security leaks. How can that be addressed using Stride?
So like I mentioned in Stride, right? Like, first of all, if you look at the, spoofing, the first one, education is very important. Like I said, like when you are doing it, because it happens to me, trust me, last night, if somebody was trying to hack into my house system, my kids were watching TV and they were told to give remote control of the TV to someone. I don't know how it happened. So it happens. My kids know, even though they're like 7 and 10 years old, that how do you react, because they see me like always screaming at them. But what you do need to do is education. I think like live, replicas of the spams. So now few of the industry companies are making mandates. For example, if you click on 3 spoofed emails, you're fired basically. So they're not allowing more than 3 chances. So for example, randomly somebody will send you a spoof email. And once it's fine, right? You click on the link, you get training. Second, warning. Third, a letter to go. So it's not like you should implement the same. It's not a good, methodology, but yes, the education is important. And that comes with, because everybody feeds on the spoofing and the fear and panic, which you had, it happened to me. I always say that make sure you have a trail of, emails or whatever it's coming from, so you actually can filter it out, for next version. One is fine, but again, nobody can, like I said, we always learn.
And then, sorry, the last question, I think you will address some of this later on in your presentation, but maybe you can say just a few sentences here. It says, this presentation seems to be primarily targeted at maintainers of systems, and it contains great advice on that topic. However, how does that filter down to, say, a graduate student with minimal experience, time, and funding who just needs to run some code for their work?
Yeah, I have it. So the thing is, I start with a simple example in next 2-3 slides, and then I go to the more complicated example. So I had it both because I teach this class also and security, and I know how it's gonna go. So I had it for both audiences, people who are basically with no expertise and people who are basically expert in systems.
Okay, sounds perfect then.
Right.
Thank you.
Thank you. Thanks, Eric. All right, so let's talk about how do we deal with both. So Stride here helps us to identify and categorize the risk into all STRID categories. And basically, we try to do DFD diagrams, and the DREAD, here assess the risk and gives them a score. So basically, Stride was more, into systems. Now we have quantitative and qualitative both together. Once we get that, we prioritize the threats based on the score, and then we try to mitigate, have the mitigation strategies basically to deal with the threat which is the highest DREAD score. Then we try to apply the strategies and try again keep reassessing, because it's a loop, right? You do keep going till you basically meet the organization standards, which are really important because organizations these days are trying to develop more standards, right? Not because of given scenario, but still they are lacking. Then you document all strategies and chances, because you need to make sure that whoever comes after you, if you're a consultant, they should know what was implemented and how and what was changed. And you keep performing this risk assessment regularly. So now let's start with, how do we use Stride? So like the first thing which we have to say is we have to understand it from an adversary's view, right? And now open up your, basically malicious eyes and see what is valuable, right? Characterize your system security using use cases and misuse cases. Use cases are the functional, that means what function my system performs. Misuse cases, which nobody actually talks about, is basically what can my system do which I don't want it to do, or what can be used by the malicious person, are the misuse cases. Once you know those, you try to create the data flow diagram. What happened? Can you see my slide? Data flow diagram. And then you identify threats using Stride categories. Then you try to determine risk level and develop mitigation strategies. Then you document all the threats, risk, and mitigation strategies together. So here's an example. We start with a simple, plain example of a car optimizer. So some or few of us are into cars, right? I love cars. So I put up this example with one of my students did it, the project on this too, car optimizers, which basically is a software system, which is used for, it's a hypothetical system, right? Just for using the example for Stride. For individual who wants to optimize their car's performance, software will feature numerous makes and models of vehicles for the user to choose from, covering all the main manufacturers. After they choose their car, they will be able to view its performance from the factory. In addition to the car's factory performance, they will be able to choose different parts for their car and see how their car will perform with performance enhancement installed. Not only will the user be able to see the performance of their vehicle with these new parts installed, but also they will be able to see the cost and a guide on installation. User will be able to configure different vehicle specification and see how they will affect the performance compared to how the car comes from the factory. So we're trying to optimize the car. So here, there's a few of the use cases, the functional requirement, right? What requirements are the user stories which are given to us by the stakeholders or to develop a software. So first will be login. We need to have a login. We can view part, then we can do make car configuration. We can manage database. We can view gallery of different configurations. We can access user profiles, access some logs, log actions, manage user controls. So all of these functionality, these are the use cases, what I want as a user or as a stakeholder in my particular software. Next is, if you look at this is the use case diagram. Here, it basically depicts on the left and the bottom sides who all of the actors of my software. That means who basically are interacting. For example, there's a professional user, customer support, manufacturers, right? Affiliates, inventory managers, moderators, at time, right? So what's missing? We are missing again the security requirements. There's nothing about security in this. This is the traditional software lifecycle. We get the requirements from the user or stakeholders, and we try to develop our use cases and try to start designing our software. What if I add misuse cases? That means we try to address security attacks. That what can go wrong now? Somebody can tamper database, right? That means hackers may try to tamper the database or system logs to manipulate them. Mediation, where we have to also not only have to misuse cases, but we also have the mitigation cases where we have to check access control to ensure that unauthorized access cannot be gained. We will implement two-factor authentication to further prevent this. Unauthorized login, we're trying to attempt gain. They are not authorized to have. Again, we try to mitigate by checking credentials, limiting multiple login attempts, two-factor authentication. If you are trying to modify input data, you try to, attack will be attempted to input faulty or malicious data into database to the front end. What you do is you try to sanitize and validate user input. Next, if you're trying to steal user information, that means attacker might try to attempt to view user database tables to gain access to sensitive information. What we need to do is we need to have access control mechanisms, encryptions for this data to be implemented. Then lastly, for example, is access system logs, where attackers trying to access and manipulate system logs. You again need to implement access controls and two-factor authentication. So what we do is we try to add use cases that are already there. If you look here, I added a misuse case as an actor, which is basically our malicious user, which can do these use cases. So these are the use cases in red are the use cases which adversary will do. Tampering, accessing, attempting, right? And then on the right side, the mitigation, security cases, which will be implemented along with these use cases. So traditionally, only use cases were implemented, misuse cases and security cases were not. Now, if you want to design for security, make sure these are also implemented as a functionality in your data in your software. Once you're done with this, you try to create a DFD diagram, which is data flow, which will help you to determine different external entities interacting with your software, who can be also malicious user, and you can see which are the entry points and exit points of a system. What is going in, what's coming out. So once you do this whole context diagram of car optimizer, you can basically dig down into the level 0, which basically give you a more enhanced view of your software. And then if you look at the dotted lines here, these dotted lines basically talks about that, here is the entry point of data, which can be used by the malicious person for attempting unauthorized login, right? So you can basically have hijack session, tampering. So if you keep digging down into your DFD, you can look into how data is flowing and how the data flow can be tampered or hijacked or basically used by malicious user to access to your system. So it looks very tedious. Yes, like I said, it requires some knowledge, but again, there's the Microsoft Threat Modeling tool, which can also help you to basically, develop DFD. Here, it's very easy. You can have your different functions, and then each of these lines depict an entry point or exit point where you can actually add what kind of threat it is, what can go wrong with this entry exit point, and what you have to do to mitigate those particular threats. And then here is a boundary, which is basically how the different attack surfaces can be attacked by using malicious person. Now, this is the example of the one of the entry point. If I basically I'm using the tool, I can say the potential process crash or stop for review content is one of the threat which has priority high. Category will be denial of services. Description I'll add to it. Review content crashes, halt stops, run slowly in all cases, validating availability metric. Justification, we have to do thorough code review, debugging of the mechanisms. Now this you can implement, and by the time you implement all these threats in the threat modeling tool, you will have basically 300 to 400 page report, which will list all the threats, all the mitigation you have in place for these threats. Now, next example I have is for more, HPC users. So post-AI is a platform designed for collaborative development of therapeutic compounds against COVID-19. It allows the research and scientists to contribute the compounds by submitting molecular structure. The site facilitates the collection, analysis, and prioritization of these compounds for synthesis, simulation, and testing, providing a unique collaborative approach to accelerate COVID-19 drug discovery. So this is a typical example of how, being in HPC, we actually use the data from different sites. We actually try to collaborate. We use different portals for collaboration. We document in different collaborative platforms. And then we are also trying to submit our jobs to HPC cluster, depending upon the data we have, and try to publish our findings, right, and have discussion and feedback. So here's the use case diagram, right, of our our post-era.ai. If you look at, if you have users, I've just made it simple, so that, very, very convenient. So if you look at this side, right, these are the use cases, right? So what basically we need from this, what we have in this portal, that means that we can submit the compounds as a user, we can draw the design, we can collaboratively, review the designs, we can change the parameters, we can submit a simulation to a cluster, we can terminate the simulation, we can log in, we can, basically try to create a post, comment on a post, we can participate in discussion, we can like a post, delete a post like we do, we can track our submissions, we can see what compounds were submitted, we can search for different compounds in the system, we can check availability. So that's all, the functionality of our portal. Now, this is what basically a malicious user can do, right? So tampering, right? We can basically tamper the simulation. We can cause the data to be manipulated, right? For example, there is a compound. I can change the compound and submit there, right? I can log in as a famous scientist and change the compound. How do you know it's not coming from me? It's in the database. I can tamper it. I can easily disclose the information which is not meant to be disclosed. I can use the supercomputer time for doing blockchain simulation. So if you look at the one attack which happened in 2021 was most of the supercomputers in Europe were hacked to do the blockchain cryptocurrencies simulations, and they are still shut down because nobody could figure out how people got access to these clusters. Again, you can have different, you can spoof, you can do phishing, denial of service. So these are the attacks. And what you do is you try to have a mitigation strategies for these attacks, where you have to have system logs, encryption, MFA. I don't discuss about these. So once you know what can go wrong, what you need to implement to avoid these, threats, you basically try to come up with a DFD, right? DFD is simple, context diagram, like what post-era can do. You can have different compounds data submitted to supercomputers per cluster. You can have a user which can do the forum response, submit the compounds or post a result. There's discussion board, there's a feedback from admin. Simple, basic examples. Now, this is the more detailed view, right? So of DFD, suppose I have compound submissions, we have feedback, we have forum interaction simulation. For example, if I look at the right side, right, on supercomputing cluster simulation, right, if you look at these different, so if 3.0 is COVID-19 simulation, I'm trying to simulate the compounds on the cluster. So what can go wrong? Data theft, right? Job data disclosure can be done. Tampering data, somebody can manipulate the files and loss of fidelity can happen. Denial of service, somebody can saturate the network. Spoofing, somebody can basically tamper with the scheduler configuration. That means if you are supposed to have the best queue, you get the last queue, the slowest queue, and you will never get a chance to basically submit your compound. In discussion board manager on the left, you can basically have different type of tasks like tampering. Somebody can modify your content. Like, how do you know that? Suppose, I'm working on a Google account, and we all are sharing a result. Suppose tomorrow is a proposal due, and somebody basically copy and paste or delete my paragraph. Who knows? Are you checking the logs? There should be a more logging technique. There should be a exposure there. There should be a admin identity, forgery or some kind of mechanism which will help you to give you feedback. So there are multiple of these spoofing, tampering, reputation, which can happen in all of these levels. So this is what is required when you do the designing of the stride in your model. Now, lastly, going to talk about, I have only like 5 more minutes before I take questions, is SAS and DAS tools. Static analysis tools are basically used for code cleanliness and finding security vulnerabilities. You have different tools like, if you're using Java, you have TMD or spot bugs. CPP check helps you to do for different type of checks in C++ code. You can do dynamic analysis using OWASP, ZAP tool, or pen testing, which combines both static and dynamic analysis. So what's static analysis? We are trying to basically test our computer program without examining the code, without executing it. We're trying to address weaknesses in source code that could lead to a different vulnerability, like in buffer overflow, a common software vulnerability, right? We're trying to address, find various type of checks, right, against different vulnerabilities, like automated variable checking, bound checking, class checking, memory leaks, resource leak, dead code elimination, performance errors, and undefined variables. Dynamic analysis, which is the pen testing, is basically we're trying to pretend like an adversary. You try to break in, you're trying to basically run the code, execute the code, and try to test it on your system on pre-created set of tools. For example, Kali Linux is distribution based on Debian. It's pre-installed with 600 pen testing programs, including Nmap, a port scanner, Wireshark, which basically scans the packets, and OWASP, which is basically the open web application source vulnerability, which will help you to find the vulnerabilities in your applications. You can use pen testing, before the release of your software. 5 phases in pen testing will be reconnaissance, which we are trying to discover domain names. Basically, they're trying to gather intelligence on your system. For example, I'm trying to hack into your application. I can actively use reconnaissance using the network, or passively by not touching the network. I can scan the ports for the IP, which I figured out, which can have some kind of vulnerabilities, and then try to sniff it around the ports, which can be open, like Samba port can be open, and try to gather data about your application. Then once I know, like this is the application server I need to hack into, I need to gain the access from system point of view to get control access. And then once I have the access, I will maintain a backdoor to maintain an access. Once I have done, patching up, because you will be working ethical, pen tester, so you will be basically patching up your application because you are acting as a hacker, not as a hacker. So you will, when you patch up everything, all the vulnerabilities in your system software, you have to also cover tracks when you get out. You need to escape the security, you need to clear everything, so nobody can know what kind of attacks or what kind of vulnerabilities existed in your system. To conclude, secure software development enables organizations to anticipate threats rather than reacting to them. It's a proactive approach. It helps you to prioritize the resources, allowing for an organization to focus on most significant vulnerabilities first. It helps you to promote the development of secure software, and also help to reduce the risk and cost of cybersecurity incident. Here's a blog. If the slides will be posted, I think, on the portal, and the blog has linked to, I think, 6 slide decks, which has more than 200, 300 slides on different topics of software development, of different cycles, of different static analysis tools, dynamic analysis tools. If there's a question about grad student, right? If you're looking into different tools, but you need to implement and use, they're all there. You can use all the resources to develop, what kind of application you're looking into. So it starts with the introduction of secure software. Then you have security, then threat modeling, different threat modeling. Then there are some kind of the real use cases of threat modeling techniques, followed by the static analysis tools and dynamic tools, which you can be used in your securing the software. Thank you. With that, I'll take questions now. I have, I think, 7 to 8 minutes.
Yeah, no problem. Thank you very much, Nitin. Thank you for a very comprehensive introduction to the security perspective on secure software development. There's a question in the Q&A. It's probably a good place to start. It says, do you plan to collaborate with those in trustedci.org?
Yeah, sure. I think trust.ci.org is already, like, they do the workshops, all over the place. I actually go to workshops and listen to different, tutorials in which they are offered. Yes, for sure. Yeah, that's basically a really good way to go. Thank you.
Thank you. Another question is, Alfred, do you want to unmute and ask your question? Or I'll go ahead and read it. Alfred asks, Stride and Dread are developed by Microsoft. Do they work on Linux? If not, what are some alternatives for Linux?
Yeah, they work on every different. So the thing is, they are methodologies, right? They're not specific on to a software or to a software, portal, anything. if you look, there are categories, which can be basically any, it can be implemented on any kind of, OS or whatever you're working on. So it's not specific. It's made by Microsoft, but it's not specific to a platform or to a software.
Thank you.
So that's all the questions in the Q&A doc. I'd like to open the floor for anybody else who wants to unmute and ask their question directly to Nitin.
This is Mike Haru. Can I just ask a question? Is that okay?
Yes, sure. Thank you.
Yeah, thank you. Thank you for a very nice talk. So a lot of us work on things like, scientific libraries and tools, and, that are used in specialized situations and platforms. And a lot of the vulnerabilities and threats that you mentioned, it may not be as relevant as others. And I'm just curious if you've seen or have content that addresses, very specific software situations, as I'm describing. For example, let's say you're developing a scientific library, it gets embedded in an application. And so it's, direct vulnerabilities. There's not a chance for, any kind of SQL insertion or that kind of thing. A lot of the software as a service type stuff, at least it seems to me that our vulnerabilities are more specific and more isolated. And often I think it's, just if we do a good job of writing correct code, where we don't, for example, overwrite memory or, do anything that's unintentional, that we're doing an okay job at least. What are your thoughts?
Correct. Thing is, so when we try to, like you mentioned, right, when you try to have the use case of your scientific library, right, which is to be embedded in a different program or something, yes, you might have a security by obscurity because it's basically secretly, hidden in the software. But again, that's also sometimes it's basically, attracts the malicious people to think about what's hidden, right? So sometimes you cannot achieve it. So if you try to look into what data is flowing, how your library is interacting with the main API or with the main software, that's the only entry point. If you cut down that entry point or secure that entry point, then you are secure. So if you are designing it already from that point of view, from the beginning, that's the goal, right? That's the best way to do it. But if we have never thought about it, you just think that, yes, we will have none of these vulnerabilities because we are embedded inside a software. That's a wrong opinion. I will say that, for example, if you go on here, like for example, right, if I'm trying to put, a user and trying to, talk to the post era, and then I have a review feedback inside the post era, right? I'll say nobody can interact. But if I know these dotted lines, you see that, these 3 entry and exit points, and if you basically secure these 3 entry and exit points for all the misuse cases which you can think of from adversary point of view, you are secure. But sometimes in rush, because we try to implement, in pressure, because you all know how we work in scientific world, because it's not industry, we are just doing to publish papers, most of us. We avoid this checkings. We are saying, okay, we have this, it's working. I've seen many of the, I will not say the names, but people trying to, collaborate and, say, okay, I have this scheduler, I have this, let's work together, right? Yes, but, once I have this big software, it can be hacked too. It can be used as a hack to your university or to your lab. So might be it is right now secure, but might be there's something open there in the mainframe or main software, which is using your library, which can be used. And then once that software is hacked, your library, which is supposed to be proprietary or classified, nobody should know that. That's also exposed along with the main software. So like I said, when you outsource the software, or if you're thinking that it's outsourced, it's main software problem, but that's basically, if you're giving somebody your code, it's actually your problem too, to see like if the people who are using the code or your data are using it in a meaningful way. That's
Okay,
the
I'm gonna have to
disconnect.
stop you there.
Thank you.
Yeah, let me thank you one more time for giving your
Thank you
presentation.
all.
Today. We enjoyed it very much, and that will conclude the seminar today. So thank you everyone for joining us today.
Thank you all.